Hello, welcome. Happy Friday, everybody. It's been quite a week. Last Friday of the month. Can you believe that we're going into April? Pretty crazy. Happy to be here. Happy to be here on a Friday. We normally do these things on a Wednesday or a Thursday. But today we're going to do a Friday. It's been a little bit of a crazy week, busy week. So hopefully Friday will do. And we'll let people jump in. I know we're starting a minute or two late, but hope you're enjoying yourself. Grab a drink, finish your coffee, have some lunch, whatever it is, wherever you are. And we'll go ahead and get started. So, thank you for joining. My name's Talon Miller. I do technical marketing at Redis. And today we're going to be talking about persistence. So, the agenda today, so you can keep track of where we're at. It's going to be a decently quick presentation. I doubt we spend longer than 15, 20, maybe 25 minutes. And I'll do I'll go through the agenda. Why don't we do that? First, we'll deep dive into persistence and why it's important, and then cover the different types of persistence available in Redis. And then we'll go over the advantages and disadvantages for the types of persistence in Redis, and even cover some frequently asked questions that I get with this topic. I've presented this topic a number of times. I've done a number of videos and other things on it. And they're our usual same questions. I'll cover those. And if I don't cover your question in that, we'll do some live Q&A at the end as well. But before we do that, I'll also demo how to set these types of persistence up in the source available version of Redis, as well as Redis Enterprise. So let's go into, what is persistence after all, right? So let's think about the definition for a second. If something persists, it lasts. So we can think of data persistence as data that lasts. Lasts what exactly? Well, if you are setting up persistence for a database, you intend for a piece of data or information that is going to be saved in some way in memory or on disk for some period of time, right? Well, so not only saved but also recovered again, I think is the important part of persistence too. That's kind of the whole last thing. You can be recovered again, even if a computer process is killed, which happens on planned events and of course happens sometimes during unplanned events, which of course can cause some data loss for certain setups, if they're unplanned. With data persistence, existing data from applications stays intact between sessions, preserving it for use in a following application session without suffering data loss. I mean, a really good example of this, there's this I'm sure this is pretty obvious to most of you, but just to kind of put an example to it, there's this financial app that I love to use. It's browser based, and the free version has no session data, right? So you can use the application, you can put all your data into it, and it does some really cool things, financial planning type stuff. And then the way to kind of get you to pay for a subscription is it's persisting your data. Actually, it's like, okay, well, once you leave this tab, once you close this tab, we're wiping the data. You're not going to have any session data, any cookies or anything. We're not saving any of your data, which is kind of nice, right? But if you do want to come back and come to this planning and all the setup that you've done, pay us a fee or whatever, which I think is pretty cool, kind of a cool way. But anyways, before I go on a tangent, before we move on to what persistence options are available in Redis, let's first discuss what ephemeral versus persistent storage means. This diagram helps visualize a bit what I'm about to describe. So in cloud native deployments, such as a public cloud or a private cloud or virtual private cloud, ephemeral storage cannot be used for data durability purposes. Ephemeral storage, also known as volatile temporary storage, disposes of data once its corresponding container reaches its end of lifespan. Usually you see when you're setting up some sort of configuration on an app or a database, you can set a time to live, right? TTL. And this is mostly related to ephemeral data. You can of course use something like Elastic Block Storage or EBS in AWS, or Microsoft Azure Disk Storage, or Google Cloud's Persistent Disk for network attached storage, so that when a cloud instance fails, which is relatively common actually, the content of its local disks are also lost. So that makes persistent storage, or non-volatile storage, which of course means a storage device capable of keeping data intact and available when it's no longer powered on. This concept, of course, is very critical for use cases or applications that need to handle critical data, or simply need to persist data for user experience. Shopping carts, for example. I'm sure 10, 20 years ago, persisting shopping carts was definitely not a priority, but now it is. You think about a website you go to, you add something to the shopping cart, but you're not sure, you let it sit there, and you're going to get emails, you're going to get reminders, hey, you've left this in your shopping cart. They're holding on to those shopping carts. That data is being persisted. A hard drive disk drive is a common example of a persistent storage device. A Redis enterprise cluster designed to work with network attached storage for persistent data, as we can see here on the screen. By default, every node in the cluster is connected to a network attached storage resource, making the cluster immune to data loss events like multiple node failures. And with no copies of the dataset left in RAM, this data durability proven architecture is what, kind of we're seeing on the right, which is kind of the right way to do it. So let's jump into the types of persistence in Redis. First, we're going to cover what's called append only file, or AOF. I'll be saying AOF a lot. Just remember it means append only file. It's a logging mechanism which writes a log file on disk every write operation performed on a Redis database. The log file is used to reconstruct the database in the event of a crash or failure. AOF works by appending each database write operation to the end of the log file, hence the name append. Append means add on to the end of what you previously had. When Redis restarts, it reads the log file and re-executes the write operations preserved in the file to restore the database to its previous state. So it has to go through all the executions that it's previously done on its append file, which is kind of interesting. Most people don't know that. AOF provides better durability than snapshot, or other persistence options, which we'll go over in just a second. You can configure AOFs to be rewritten to the background when it gets too large using a process called AOF fsync. The fsync configuration controls how often the AOF log file is synchronized to disk. So this is really helpful for those that are really trying to control their data, as large data sets tend to be a problem with append only file, which we'll touch on when we go to the advantages versus disadvantages. Lastly, something good to know about AOF is that there's been a recent update which reduces the memory consumption and the amount of I/O operations that are performed during AOF rewrite, which is pretty cool. All right, let's go over RDB, or Redis database, aka snapshotting. I'll probably refer to it as snapshotting or RDB going forward. So it's when Redis, it takes a point in time copy of the data stored in memory, and these snapshots are created using the RDB option, which allows the state of the Redis database to be saved to disk at specific intervals. When an RDB snapshot is taken, Redis creates a child process to perform the snapshotting, allowing the main process to continue serving requests. Snapshots are useful for creating backups of the Redis database, as well as for migrating data between Redis instances. They can be created manually by using the save or bgsave command, or automatically in the config file, which I'll show you in the demo. It is important to note that while snapshots allow the data in Redis to be persisted to disk, they don't provide the same durability as AOF, which I think can start us off on a really good note for advantages versus disadvantages. So let's go into that, because I think this is most people's questions. I think that when you do come to a persistence type discussion like today, it's like, oh, which one should I use, right? Well, this next slide should help, and also my frequently asked questions. So let's get into advantages versus disadvantages. I've kind of covered some of these as I've described them, but let's just put them to point. So let's start off on the very, very left, the AOF advantages. So it has better durability, which I've mentioned, and well, because it logs every write operation, reducing the risk of data loss. It also stores commands in plain text format, making them easy to inspect and understand. Lastly, you can configure the AOF fsync policy to balance durability and performance based on your requirements. So there's a little bit of flexibility there, which is nice. AOF's disadvantages are that you start to build up large files. They tend to be significantly larger than RDB files as they store every write operation, as I've mentioned. Also, the recovery process for AOF can be slower than RDB. As Redis needs to replay all of the logged commands to reconstruct the dataset. So if you imagine if you've got a very large append, a very large append only file or append file, let's say millions of commands that needs to go through to reconstruct the data set on a machine once it restarts. It can take some time for sure. On to RDB. RDB's advantages are that RDB files are highly compressed and optimized, which reduces the disk space usage. RDB also has much faster recovery times as it contains a full snapshot of the data and doesn't have to execute all the commands. Lastly, RDB snapshotting process has minimal impact on Redis performance as it occurs in the background. RDB's disadvantages are that RDB snapshots are taken periodically, which means that in case of a system crash, you could have some lost data because maybe that happens while it was not yet included in the most recent snapshot, right? And finally, the Redis process needs to fork a child process to create an RDB process, which can be resource intensive for large data sets. It's not a ton of resources, but resources looks differently from company to company in regards to what's utilized, what's expensive, what's not expensive. I think it's definitely something to note. So I can imagine that this slide could create some questions because they both have really great things, and they both have some things that definitely aren't super great. Just kind of a trade-off thing, right? So let's kind of go over some frequently asked questions to help you kind of make sense of what could be right for you and your use case. So let's cover my frequently asked questions before we move on to the demo. So here's some frequently asked questions. Can I use both AOF and RDB at the same time? Yes. So you don't have to be stuck with one or the other, which is great. If you do need durability, as similar to like a traditional RDBMS, then people do typically use a combination of AOF and RDB together. It's a good balance of durability and performance, where AOF provides the better data protection, while RDB allows for faster recovery and more compact backups. So to question number 2, how can I choose the best persistence options for my use case? Well, I've included a link at the bottom of the page, which goes over a lot of details on like why I would want to use one over the other. And also this is definitely the most commonly asked question out of these 8 questions. And unfortunately, it's not easy to answer, right? Because it totally depends on your requirements, or what I like to say, tolerance for data loss. So I guess what we can do, just to at least kind of give you an answer for, which one should I use, if that's what you're wondering, I would ask yourself and your business, is data loss acceptable at all? Some will say yes, absolutely. We don't have a critical use case where if data gets lost here, like operations go down or we lose revenue. Other business use cases are going to be like, oh yes, we absolutely cannot have any data loss. So what I would do is work backwards to how much data loss is acceptable, and then you can start to figure out what options are best for you. Third question, Is it possible to convert an RDB file to an AOF file or vice versa? Yes. You can convert an RDB file to an AOF file using the Redis-check-RDB tool, which should be in your default installation of your Redis, source available, or an enterprise. Similarly, you can convert an AOF file to an RDB file using the Redis-check-AOF tool. All right, next question, number 4. What happens if the AOF file becomes corrupted? Because we've just talked about how we're going to continually back it up and append more and more executions to it. So this is it's a fair question for sure. So you can use the same tool I mentioned before, which is the Redis check AOF tool that can fix corrupted files actually. So that tool is pretty cool. Check it out if you are using AOF or RDB. The check tool, essentially. It's Redis-check-AOF or -RDB, depending on which one you're using. Next question, what is the performance impact of using AOF versus RDB? And this is an important question, definitely a common one as well. So AOF can have higher performance impact than RDB, especially when using always fsync policy, where you're always appending every write operations. RDB, on the other hand, has lower performance impact, and as it takes snapshots and then saves them periodically. As I've mentioned, using just the save command can halt connections, so you can use the bg save command to avoid that. We have some benchmarking on our site. If you look up enhanced storage engine Redis, I'll actually just type that in chat. It might take a second to cross over to LinkedIn because I'm on a different platform, but I'll go and type this in really quick. It's called enhanced storage engine Redis. So if you just type that in to Google, the very top result will be some benchmarking on the very bottom of the page. Looks like I can't send this, so I'll have to go in LinkedIn and send this. But so essentially some benchmarking of RDB versus AOF, just so you have an idea. Okay, next question. So how can I configure Redis to minimize data loss in case of a crash? To minimize data loss in a crash, use the AOF method with the every second fsync policy. So it's going to be appending every executable command that's been happening every second. But like I've said, a combination of AOF and RDB will provide the best durability with faster recovery and more compact backups. All right, next one. How do I migrate data from one instance to another? So yes, if you didn't know, you can migrate between instances. You can use RDB or AOF files and then stop the source Redis instance, copy the file from the source instance to the destination instance, and then configure the destination instance to use the copied file, and then start the destination instance. So it's actually really simple, but a good thing to know. And then final question, are there any alternatives to AOF or RDB for Redis data persistence? And yes, there are. Redis Enterprise has auto tiering, which is a capability where you can extend a Redis dataset to flash or SSD, which of course is a lot cheaper than RAM while maintaining high performance. So if that's an option that you would like to look in, certainly you can ask me in the chat about it. Or of course, we've got lots of content available on our website and on YouTube about auto tiering as well. It's really cool. Okay, so let's jump into the demo. Before I share my screen and go through Redis Cloud, I figured I'd just cover the commands on the Redis Community Edition or source available version. So it's very simple. I've kind of listed the file here that you'd edit. If you're a Redis expert, this is going to be like very familiar. This is definitely Redis 101 type stuff, I feel like. But it's as simple as editing some of lines in your redis.conf file and changing the default from append only no, kind of delete the yes and delete the no and replace it with yes. That would turn on append only file. If you want to do an append only file for every second, and then you need to edit the fsync line, as I've listed below that one. Also in the redis.conf file, you can write, save and then enter the seconds amount of changes, which specify the conditions, creating the RDB snapshot, like I've listed here on the third line. The example that I have here, obviously, is to create a snapshot after 60 seconds if at least 1,000 keys have been modified. What isn't talked about a lot, actually, which I love to bring up and isn't commonly known, is that you can have specific multiple conditions. So most people think that if you're going to do RDB or snapshotting, they typically stick with one condition. You can actually have multiple conditions. Would love to hear from those in chat. If you have multiple conditions set up right now, let us know how many conditions you have set up. I have heard of people having 6 or 7 conditions that would have to be met in order to take a snapshot. I think that in those scenarios, I think they were also using a append only file as well, but either way, kind of cool. Obviously, with the Redis source available version of Redis, you need to do this manually, and which obviously is tedious for doing each one of your nodes. It makes upkeep, maintenance, and making changes really tedious. And to that point, I'm going to stop sharing my slide deck here. What I'm going to do is share my screen for Redis Cloud, and I'll show you just how easy it is to enable persistence options on Redis Cloud. So give me just 1 second. Share screen. Redis Cloud. Okay. So I've got a couple of test databases up and running on my Redis Cloud instance. As you can see, we're on the test persistence database. It's on a fixed plan or fixed subscription. So I'm going to name my database really quick. Let's just say this is persistence database test. We're running on Redis Stack, which of course contains all of the Redis core data structures and advanced data structures like search and JSON. And then we have high availability on, which is basically replicating multiple nodes or replicating our data to multiple nodes, as you can see here. So here we are, data persistence. So as you can see, we've got our different options here. So very familiar with what we just talked about. This should be pretty simple for us to understand, and it's really easy for us to just enable. So we're doing this by database. So instead of like the Redis source available version, you need to apply it to each node that you spin up. This takes a different approach where we've got our subscription set up. We've got a certain amount of nodes, but this is going to be by database. Now we need to select whether we want append only file every second, or if we want to do a snapshot every hour, 6 hours, or 12 hours. So, let's say, for example, I wanted the most amount of, potential for non-data loss, then I would do append only file for 1 second. And some other options, of course. But it's as easy as that. If you haven't been in Redis Cloud, the console is very easy to use, very user-friendly. So with that, let's go back to the slide deck, and we'll kind of move over to some questions. Let's see. Okay, sure. Okay, awesome. With that, if there are any questions in chat, please let me know. I was having some issues. It looks like, read only right now for me for LinkedIn. So I can read your chats, but I cannot reply. So if you want to ask me any questions in regards to Redis, persistence, whatever it is, be happy to talk about that more. In the meantime, since I don't have any right now, I guess I'll talk a little bit more about auto tearing, which is really cool. The reason why it's called auto tearing is because it automatically sends keys to SSD depending on whether or not they are used or not. So it kind of automatically does that. It's like a no code option, which is really cool. There's definitely some use cases where it makes a lot of sense. um, and maybe some others where you might need to talk to some of people, some of the people here at Redis to see if it makes sense. But I told you about shopping carts already, keeping shopping carts. In that hot RAM might not be the best option because it's expensive. So what I'm seeing and what I'm seeing our customers doing is keeping all those shopping carts in SSD or in auto tiering so that they're still warm. They're still very high, very readily um, readily available, right? So if someone comes back to the site, they don't have to wait a couple of seconds to see what's in their cart. It's readily available, but it's not in RAM. It's in SSD. Another good example is leaderboards. Well, not leaderboards, but gaming, for gaming profiles. So you think about, the average, life cycle of a gamer. They're usually going to have different times of day they play. And so when they're not playing, certainly don't need to keep their active information, their active profile information in RAM. It can be stored in SSD. So, anyways, some couple examples there. Hopefully, that gives you an idea. Like I said, if you want to learn more, we got plenty of content online about auto tiering. With that, I don't see any questions, so we'll go ahead and end it here. Before I close it off, I just want to say thank you for joining. I hope you enjoyed this. Hope you're going to enjoy your Friday and your weekend. We've been doing this monthly operator workshop for quite a while now, and we're actually going to be moving this over to what we're calling a new demo series, where it's going to be primarily focused around demoing products and use cases and really cool things on Redis. So look forward to that. So yeah, next month we won't have a monthly operator workshop, unfortunately, but we will have our first demo series May 2nd. So a little bit of a gap there. Usually we do something at the end of April, but 2nd of May, not too big of a gap there. So hope to see you there. I believe the first demo is going to be an intro to Redis. So, and it'll be mine. So there's going to be multiple speakers, but the one on May 2nd is from me. So if you do want to join on May 2nd, I'll see you there. And for now, enjoy your weekend and hope to see you again. Bye bye.